Okay, so it's been pretty complex with the exponential rules here. We're trying to get you to understand, algebraically and graphically, these worlds go together and what is the same as what. So remember, we had this situation on one of our practice sheets on the last unit, but the relationship between these graphs, if you remember, if you did that practice sheet, was that they were exactly the same. So, not to go too fast here, but when we had 2 to the negative x power and I had you graph that and you had base 1/2 to the x power and graph that, they ended up being the exact same graph, okay? So what does that mean? That means if I take base 2 and I do a horizontal reflection, that's going to be the exact same thing as base 1/2, just a normal exponential function. So what's the algebraic proof for that? All right, well, basically, we would start with f of x, okay? So how do we show that these are the same? Well, algebraically, remember, we're going to ask for both here throughout this unit. So algebraically, we would say, okay, let's start with this, all right? Well, what is that the same as? Well, that's the same as 1 over 2 to the x power. Well, that's exactly the same as, like with the 1 on top, like we talked about, that would be the same as 1/2 raised to the x power. And what do you know? That is equal to g of x. So we can algebraically show that that's true. Now, what's the verbal summary? Again, we have an exponential base 2 with a horizontal reflection. Again, you would want to be, I don't know why I always abbreviate that, REFT. Okay, reflection. So exponential base 2 with horizontal reflection, and that's going to be equivalent to what? Well, that would be equivalent to base, exponential with base 1/2. That's it. No transformations at all. So that's how you just basically want to put in words what's happening to those graphs with the transformation. So here we go. In practice here, give the parent function p of x equals 3, so exponential 1 with base of 3. Well, what's the, to kind of see how this all lays out here in progression, describe the graphical transformation here from its parent function. Well, nothing new, nothing crazy. We would go left 1. You all know that. Describe the transformation to this parent function. Okay, so now we have a multiply by 3. It's a vertical, it's an integer. Okay, so it'd be a vertical stretch by a factor of 3, right? Vertical stretch by 3. So then we go and we have algebraic justification as to why they're identical. Okay, so how can I do that? Well, I can start with one and get to the other, just like we did. So basically we have f of x equals, 3 to the x plus 1. Okay, well then we talked about up above in some of those examples, we're like, okay, well that, if we go the other way, would really be 3 to the x times 3 to the first, because that's the rule, the other direction. All right, well, what does that mean? Well, that means that's equal to 3 times 3 to the x power, which is identical to g of x. So there's our algebraically showing how this one is equivalent, f of x is equivalent to g of x. For a base 3 exponential function, left 1, and you could really say that better, horizontal shift left 1, does the same to the graph as vertical stretch by 3. Okay, so we're trying to get you to understand how these are equivalent to each other. All right, so I'm going to go through these two here, and basically what I want you to do is to, I actually would love for you to try to see what these are without me. I'm going to speak them out here just for sake of time, but we're going to have you write these verbally as well. So here's the deal. The function f of x equals 2/3 to negative x power is equivalent to, well, any fraction to the negative power, like 5 to the negative first power, is equivalent to 1 to the 5th, right? So you're basically flipping, you're taking the reciprocal. All right, so what we can do is we can say it's the same as 3/2 as a base to the positive x power. So speaking this out, this would be base 2/3 with a horizontal reflection. That's going to be equivalent to base 3/2 exponential function. All right, what about this one? The function here is equivalent to, well, we can think of that as 2/3 to the 3rd power to the x. That's really 2 to the 3x. So that's equivalent to 8 to the x power. So basically, again, base 2 exponential function with a horizontal, that would be a compression, is equivalent to base 8 exponential function with no transformations. Okay, this one here, a little bit trickier, but you know, you can think about it as using, hopefully you saw the subtraction led you to think about the power. Excuse me, the power rule of subtraction. So we can write the same bases and it can look like that. Well, what is that equivalent to? Well, obviously that's going to be 36 over 6 to the x power. Okay, well that would be equivalent to actually 36 times 1 over 6 to the x power, which is actually equal to 36 out front, and then we can write this as 1 over 6 to the x power. Again, there's that rule we were talking about above and where it comes into play here. So what is this? This, in words, would be base 1/6 exponential function, vertical stretch factor of 36. Don't worry, I won't have you graph that one. And then this one, what is this one? Well, we've done this a few times this year. You got to think about it like this, right? And then you got to think about that as the negative coming out and being like this. So this is actually right 2 with a base of 6 and a horizontal reflection. So that's the exact same thing as this one. You'll get the identical graph.